In today's lecture, we will be doing a problem from chapter number 13, which is about the force analysis of spur gear. And in our previous lectures, we have done force analysis theory and an example on it. And after that, in today's lecture, we have a problem on that and let's solve it. In this problem, we have three gears which are mounted on three different shafts. The first gear is gear 2, which is mounted on shaft A, and shaft A is actually the power source which is providing the power to the gear 2, and there are 17 teeth on the gear 2. This gear 2 is meshed with gear number 3, which is mounted on shaft B, and the number of teeth on the gear 3 is 34. The gear number 3 is again meshed with gear number 4. Gear number 4 is mounted on shaft C, and the number of teeth on the gear 4 are 51 teeth. This is y-axis and this is x-axis. Shaft A is rotating counterclockwise direction, so gear 2 will also rotate in anti-clock or counterclockwise direction, which in turn will rotate gear 3 with itself in clockwise direction. Shaft A is connected with a power source of 75 kilowatt and rotating with 1800 rpm. I have written 1000 rpm, but it's not 1000, it's 1800 rpm. Since all of them are meshed together, so they will have same module, which is 5 millimeter. Here the pressure angle is 20. Pressure angle is the angle made by the line of action or pressure line with the line which is tangent to both the meshing gears. Gear 3 is an idler gear. It is consuming no power. If it is not consuming the power, then why are we using it? Why can't we directly mesh gear 4 with gear 2? So the simple answer is that gear 2 is rotating in counterclockwise direction, so it will rotate the gear 4 in clockwise direction, which we do not want. We want gear 4 to have same direction as gear 1. So for that we will have to insert another gear in between them, that is gear 3. So gear 2 is rotating in anti-clockwise direction, gear 3 will rotate clockwise direction, and gear 4 will rotate in anti-clockwise direction. We have to find F3B, that is the force exerted by gear 3 on shaft B. F3B is actually the force exerted by gear 3 on shaft B. Let's say this is the shaft B. Now how the force will be exerted? Let's draw it in its direction. This is FB3, force exerted by shaft B on gear 3. Now F3B will be in its opposite direction. Further, we have to find the T4C, which is the torque exerted by gear 4 on shaft C. Now we are going to find out F3B, means force of gear 3 on B. So let's draw Freebird diagram of gear 3. This is the shaft B, and this is how gear will exert force on the shaft B. Now let's draw its rectangular components, which are F23T, F23R, F43T, F43R. Since it is idler gear, so the radial components would almost be negligible, and we are left with tangential components. There would be reaction to these two forces at the shaft, so remove the radial components of the shaft as well. Force exerted by shaft B on gear 3 is FB3, and force exerted by gear 3 on shaft equals to F3B. To obtain the force on the shaft, we must know the tangential components, and these tangential components are also equal to each other. F43T equals to F23T. So we can say that FB3 equals to 2 times F23T or 2 times F43T. To find it, let's draw the free body diagram of gear 2. These are the coordinate axes. Here this is shaft A, upon which gear 2 is mounted. This is gear 2, and this is the force exerted in tangential direction by gear 3 on gear 2. This is the torque TA exerted by the shaft A on gear 2. This is the radial component, which is negligible or equal to 0. First of all, find out omega. Omega is equal to 2 pi n, where n will be in the form of RPM. To convert it into RPS, means revolution per second, divided by 60. Here power is represented by H, which is equal to T omega. Actually P is equal to W by T, which is in turn equals to F by F into V, where V is equal to R omega, so P is equal to FR omega. FR is equal to torque, so P is equal to torque into omega, or H is equal to T omega. Putting value of omega and rearranging it for T, we will get this formula. Here 10 raised to the power 3 is written. It is because sometime power is given in the unit kilowatt, so instead of kilo we will write 10 power 3. Replace 60 multiplied by 1000 divided by 2 pi with 9550. So torque is equal to 9550 into H by N. N is equal to 1800. H is 75. So putting the values, we will get T is equal to 398. Now let's find out F3 to T. As we know that F is equal to T by R, where T is equal to torque, we must know the radius R. R equals to D by 2, where D is equal to module M into N, number of teeth on gear. As M equal to 5 millimeter, same for all, and N2 is equal to 17. So put these values to get radius of the gear 2. 42.5 millimeter. STI is equal to F3 to T multiplied by the radius of the gear 2, which is R2. So rearranging for F3 to T, that will be equal to TA divided by R2. So putting the values, we will get 9.36 kilonewton. Now let's draw the free body diagram of gear 3. Now drawing the rectangular components F2 3T and F4 3T. Similarly the shaft reactions FB3 or F3B. FB3 is equal to minus F3B, which is equal to sum of F2 3T plus F4 3T. F2 3T is equal to F4 3T, so FB3 is equal to 2 times F2 3T. So putting the value of F2 3T, that is 9.36 multiplied by 2, we will get 18.73. Now this is gear 4 and this is the force exerted by the gear 3 on 4 and tangential direction F34T. F34R is equal to 0 or negligible. This is the radius R4 which must be found out to find T4C. R4 is equal to D4 by 2, which in turn equals to M and 4 divided by 2, where M equals to 5 and N equals to 51. So putting these values, we will get 127.5. Now TC4, as we know that T is equal to F into R, as F is equal to 9.36 and R4 equals to 127.5. So putting these values, we will get 1193 Newton meter.